Well, welcome back. Just done a very small modification to the deconvolution filter of the previous video, and I've added one of these small Adafruit OLED organic LED displays, the SSD1306, which you see a lot, and I just put a little speed display on it so that when I turn the speed sensor, which is the quadrature encoder, it displays speed. I just rounded it up to integer and go negative as well, positive and negative. I mean, it could be better. It's just a very crude thing I knocked up in a few hours once I got to know the how this the drivers worked on this. It runs on 3.3 volts off the ESP32. And this is an I2C version. Be sure you get the right type, because there's two different types actually, and the I2C one is the one I'm particularly using, so you know it's that because it's got the SCL and the SDA pins, the ground and the VCC. That's the 3.3 volts. The code's particularly simple. I don't know if we'll be able to zoom into it here. It's oops. All I've done is I had to put in a couple of extra libraries, which is wire.h, Adafruit _gfx.h, and Adafruit SSD1306, and then some simple code which I can list out and give you in the video. And I just followed this tutorial here, which is web page interface OLED graphics display with the ESP32, which is lastminuteengineers.com, and so that's probably one of the easiest ones to read. Surprisingly, when I run the examples which are on the Arduino editor thing, didn't actually work, but the ones online worked. I couldn't get the other one to work for some reason. One of the disadvantages of this is that it will reduce the sampling rate, the loop speed, as it's doing all this display stuff. Sending out stuff to the display obviously slows it down, goes without saying, and it goes down to a sampling rate of about, measuring it here on the scope, 34 Hertz. So that means you get a bandwidth up to 17 Hertz. So it wouldn't give you much of a speed controller if you only had that. It'd give you only a few Hertz bandwidth altogether. But okay, I mean, might be all right for some very, basic speed control thing. It might be fine, depending on how quickly you want to control the speed and so on. But that's it. Now perhaps try and do a quick demo of how to actually put the drill on the end of it and see if I can get it to work. I'll have to put this down now and see if I can get my drill in here, and it's going to be hard to see the display. Try to zoom in on it. Right, so I'll go and get the drill. Oh, the drill was here, and here's my sensor, and I'm just going to put the drill. See the speed. I've got speed brackets RPM. It's not calibrated in RPM, but it could be. It goes negative as well if you want to. Oops, hiding this. And of course you'll see, because the display is changing so quickly, you're not going to get a brilliantly accurate reading off that. So what you're going to have to do if you want that is to have a bit of software in there that freezes the display. I haven't done that, of course, So you're going to have something that keeps the last value and jumps somewhere and jumps out of the loop and just displays the last value of the display. It shouldn't be too difficult to do. It could be left to somebody who wants to make a project out of this sort of thing. But it would be an interesting project for a very simple speed control sensor using the ESP32. So, thank you very much for watching. It's a very brief video, and we'll see you next time. Bye bye.